Moving on, we have our very first keynote presentation on Stop Advanced Threats Invading the Perimeter by Mr. Tabrez Surve. He is the Regional Security Head, SEMEA from VMware. The stage is all yours, Mr. Tabrez Surve.
Thanks, Bridget. Bridget, just to showcase, if you guys can see my screen.
Yes, I can see your screen. Fantastic. Thank you.
Okay, thank you so much, Bridget. And it was an interesting panel discussion. I really thoroughly enjoyed it. Some insights for me too. So taking some keynotes from the presentation that Dr. Saud did and from the panelists itself, one of the areas that I wanted to cover today in terms of cybersecurity was the advanced threats that are coming in, and how do we stop these advanced threats which are evading the perimeter itself. So one of the key questions that we ask from a lot of customers and typically cybersecurity experts and CISOs is, what keeps you awake at night, And one of the key aspects that we've seen is the major thing that keeps majority of the CISOs awake at night is a breach. They are concerned that there would be some kind of a threat that would overtake the business and compromise the business in one way or the other. And there was a study done in terms of cybersecurity priorities and strategies for CISOs. It noticed that almost 72% of the CISOs are investing in resources which are there to protect any kind of breach that happens. Now, 40% of these breaches are the top IT security risks within an organizations. And most of these, 46% of these breaches are the top 3 threat that these CISOs are really concerned on. Now, if you map these breaches across with the MITRE framework tactics, let me just see. So if you map this to the MITRE framework, which basically tracks how a breach happens, how the breacher or the hacker is able to get initial access, and till the point that he's able to exfiltrate data from the organization that he has breached into, you would see there are multiple steps that these breaches go through, right from initial access all the way from exfiltration of data. But majority of these breaches, if you see, is it can be a trusted user who's got compromised, a trusted environment that might have been compromised. But the important thing is, once it's been breached, or it can be a trusted source also. Now, everybody has seen the SolarWinds thing. It was a trusted source. They were a trusted source. They were updating their software, and the download was from a trusted source. So the breach can happen at any given point of time. So the main and the majority of the attack that takes place is not when the breach happens, but once the breach happens, how the hacker or the breach person is able to navigate within the organization to search for the data or information that he wants and able to exfiltrate this data out. And according to us, that part is called as the active attack. And that is happening within your data center. Maybe your data is hosted out here within your private data center, private cloud, or within the public cloud. But once it's breached, it's not what is being breached, but how he navigates the information internally that is critical. So let's take a step back and understand how the traditional model of applications itself has changed. And some of these panelists in the earlier session kind of touched on this. We've moved from a typical 3-tier model wherein we had the application, the web, and the database tier. And we are now moving to a service mesh kind of architecture. So our apps are evolving. And as some of the panelists mentioned, we can look at the newer services and newer apps moving to the cloud. Same thing has happened with the data center. The data center is evolving, and we are seeing the data center being moved to the cloud environment itself. In fact, the branch offices are also connecting through the SASE environment to most of these, either the cloud or the private data center that exists. So what that has done is it has killed the perimeter completely. The perimeter has completely dissolved. You see a majority of the apps are now distributed. You see the data center is now distributed. So the major battleground is not in terms of the breaches that happen for each of these applications, but the traffic that moves between these applications and users within from one end of the data to another end. So, and if you look at the amount of data that traverses internally is almost 10 times than what it traverses between external to internal environment. So 80% of the traffic that is there is internal. And most solutions are focused on having a breach. But consider an environment wherein a customer or your environment as an organization has been breached. Once it's breached, what happens is it's going to move laterally. It's going to move and search for information, what it needs. The data, as some of the panelists mentioned earlier, that is critical and has become as important as oil, to be exfiltrated outside. And that's what you want to stop. And this is where it's important that your traditional infrastructure that you were having blocked for the perimeter environment does not hold good for a lateral internal environment. And that needs to be bifurcated. So as VMware, what we've done is we've come with a distributed architecture. We realize this, that 80% of the data is internal, and we need to make sure that even if a company is breached, they are not able to get to the data that is necessary. And we are able to isolate or segment that particular data into an environment wherein even the workload or the host or the app that is being breached remains only on that particular environment. It does not traverses through multiple environments. What we have tried to build in is some kind of an intelligence platform also, wherein we can typically look at any kind of real-time flows that happen between these applications and map those applications on the basis of those flows as application groups, and then formulate and give policies to be created, because most of the firewall admins, the IT admins, they are not aware what to build in and how do I segment my data to make sure that A, it's classified, A, I'm able to classify the data, B, I'm able to segregate the data, and C is to protect it from any kind of exfiltration that might happen. So create a policy and send it out directly to the firewall admin, so it kind of automates the whole process of making sure that the data is secured and protected. What we've done at VMware is basically we've built this something called as the NSX service defined firewall and ADP solution, which encompasses the distributed firewall and the IDPS system. So the standard IDPS systems and the firewalls that you see within the market are typically for the perimeter, but they do not cater for such kind of an environment. What at VMware we have tried to do is bring in a service-defined firewall which caters specifically for the east-west traffic that is there happening within your data center itself. In addition to that, what we do is we create an advanced threat protection mechanism to protect the data moving in motion itself. And how do we do that? We typically look at three main areas within the advanced threat protection. We looked at some kind of signatures that we see when the data is in motion, whether it showcases any kind of malicious activity. We kind of understand if there is malicious activity, we are able to pluck that data out and create a sandboxing environment where we can replicate or execute this data and see whether it's malicious or it's not malicious. And the last bit, which is using AI techniques, we are able to baseline the traffic that exists within the data center itself. So in summary, we are able to cater to this kind of data exfiltration and stop this kind of data exfiltration that takes place from the data center itself. Now, let's look at each of these components in detail. The IDPS system. Now, the major constraint that a lot of vendors out there and a lot of cybersecurity vendors, when they come into the data center environment, is they are not able to scale. They are not able to understand, because when you're doing any kind of deep inspection, the amount of throughput needed, the amount of scalability needed on the environment is massive. And that becomes a challenge for most of the cybersecurity vendors. With the distributed model, what we have tried to do is we are able to identify what is the workload that is going on. What is the application which is running within that particular workload, and identify signatures which are related only to those particular application and workload, and scan the data against those signatures rather than scanning it against a number and thousands of signatures, whereby it creates a number of false positive, and at the end, what the IT admin or the firewall admin ends up doing is dropping this data. So what we call it is, we take these number of signatures, we look at each of the workloads that are running and each of the applications that are running within your data center, and we curate these signatures to match those particular applications and make sure that they are scanned against those relevant signatures itself. So what it does is it basically reduces the load on the IDPS engine itself, and you are able to have fewer false positives compared to any other IDPS systems that you might have in your environment. The second bit is sandboxing. Now, over the years, if you've seen, the malwares have become also very intelligent. And you've seen the recent ransomware attacks that have happened on Colonial Pipeline as well as JBS, and very recently with Volkswagen. What has happened is these malwares have become very evasive. What they do is they understand that there is cybersecurity vendors out there who can emulate and understand that there's a malware that is running. And what they do is, one, they understand that the malware is being detonated in a sandboxing environment, they stop behaving as if they're malicious. So we typically call them as evasive malware. Now, in this particular scenario, what we've tried to do is we've tried to emulate the sandboxing environment as true as the normal environment. What I mean by that is there might be certain commands that these guys send in only to check, and this is nothing to related to the malicious activity. They might just send a random CPU command or an IO command that can happen, and understand that this is a sandboxing environment and this is not a real environment, because we need to make sure that we do not showcase ourselves as a malware thing. So with a complete full system emulation, we are able to detect any kind of evasive behavior that the malware does, and have 100% detection rate in case of any malware that comes in contact. The third bit, as I mentioned, is on AI. Now, whenever we have a solution with the east-west traffic, we try to pass on all the network traffic through certain machine learning models, which are unsupervised, which typically baseline the traffic. And it highlights whether the traffic is a good traffic, the trends are good or bad, what is the malicious activity that is happening. If we see any kind of anomalous behavior that happens within the network itself, then we take it to a supervised machine learning model, wherein we try to evaluate that this particular activity that is happening on the network needs to be supervised and checked whether it's some kind of malicious behavior that it's exhibiting within the network. And then if we see that the activity is indeed malicious, then we go back to the sandboxing environment just to make sure that we detonate this malicious activity and are able to give real-time, accurate feedback to the SOC or the cybersecurity products that are in the system itself, to make sure that these malicious activity is taken care of. So it's always not about the intrusions that happens, it's about the events that takes place. So as we comb through this thousands of events that take place, what we try to do is we try to identify where is the threat activity. Based on the threat activity that we notice around these, we then understand what is and correlate this activity to understand whether it's a real breach that has happened, a real malicious activity that has been taking place, a real malware or ransomware or a Trojan that is surpassing the network, and able to correlate that into an intrusion, and then identify that, so that when a SOC admin or a firewall admin or any kind of SOC manager, when they look at this kind of data, and any CISO that looks kind of data, rather than going through thousands and thousands of events or thousands of intrusions that might take place, they are able to zero down on real intrusions that take place within the environment itself. Finally, just to give you a context on how this works out, if there is an adversary who's trying to exploit any kind of initial access that takes place, he might typically do that using or exploiting one of the workloads, or can do it through phishing emails through the email gateway itself, and gain some kind of access. Once they have gotten access, they would typically look at executing the malware within that particular workload or within that particular host, and create a command and control center within the environment itself. And then it starts moving laterally. And this is what I've been saying initially. It's education of the users that is necessary to make sure that they understand the cybersecurity is important. But in spite of all the education that you do to the users, there might be one or two users who might get compromised for various reasons. And then that becomes the access window for these adversaries to get into the environment. But it's the motion forward that user gives in moving these adversaries internally to the data that they want to exfiltrate. That's the most critical aspect of it. And this is what we try to protect using our solution across the network itself, and make sure that they are protected. In addition to this, this is not only the technology and the AI platform that we build in that is helpful, but it's the human expertise that stays behind that is also critical and important for us. We have more than 100+ threat researchers who day in, day out do this only in terms of analyzing any kind of application behavior that takes place within each of these workloads across the environment. They analyze all the malicious traffic and the artifacts that come in, and they develop newer signatures so that they can be deployed in real time when they notice any kind of malicious activity that happens. So all in all, the idea is, even if your environment is breached, to make sure that the adversary or the infiltrator is cornered and does not get allowed to move easily across the environment, because you're securing only the perimeter and not the data center itself. And this is the aim of the game. So the idea is not to just stop the infiltrator at the perimeter, but even if he is able to breach you in whatever environment, is to protect the environment irrespective. That's about it. I'm open to questions if you have any.
Do we have any questions, Naveen, from our participants? Well, I do not see any questions, Tabrez, for you as of now. However, if we do have any questions from our respective speakers or panelists or delegates, then we will definitely shoot out an email to you with their questions. Okay.
Thank you so much, Bridget.
Yeah,
I hope I gave back some time to you,
Yes, thank you very much for your time, and have a lovely day ahead.
Thank you. Same to you.
Thank you, Tabrez. And just to conclude with that, yes, VMware is one of our strategic sponsors for the event, and yeah, thank you so much there. And if you have any questions, please do drop your questions under the Q&A tab. I'm sure Tabrez will be glad to answer those. And of course, yeah, we're running about 3 minutes late, so at the moment I don't think so we could, but definitely your questions will be shared with Tabrez, and he will respond to it. Please do, drop your questions.
Thank you so much.
Thanks, Tabrez.
Thank you, Naveen. Thank you, Bridget.
Okay, have a good
Thanks,
evening.
Appreciate it.
Tabrez. Bye-bye.